Thank you. So welcome to my session. As you can see, I'm the guy with the Kubernetes t-shirt. I have 4 of them, so I can wear them all week long. I wash them, of course, but it feels like Tony Stark kind of guy, which gives you superpower for your infrastructure, right? So Azure and Istio are also going to be covered in the topics. So maybe people don't know me because I'm a little outside my turf. I live in Amsterdam. I'm Italian. I've been there for 15 years. I run communities in Amsterdam, and I'm a community guy. I always run meetups. I run the Kubernetes Day in Amsterdam. I love this stuff. I'm not a cloud developer advocate. I'm just a senior software engineer. It's the same thing. When you have passion for these things, you just want to share it, and that's what I do all day long, sharing with you. I'm the guy pushing buttons on this little machine. I've always been around open source. I'm a chemist by education, which gives you some edge, I think. But also, I'm not gonna make anything explode today. My PowerPoint skills are really not good, so please, I apologize in advance. Yes, I work at Microsoft, which is a great company to work if you want to do open source. They are my colleagues over there, and it's just great. That was my first computer with 4 function keys, more than I needed. And so most important, I'm an ambassador for the Cloud Native Computing Foundation. Who knows what it is? Yes, cool. So as you can see, I don't do stickers, but if you do, I left a bunch of stickers over there, so don't be shy, come forward. Pick stickers. They're free. They're cool. They're all the stickers from project part of the Cloud Native Foundation. I'm going to talk a few minutes about it. So the Cloud Native Computing Foundation was founded really to manage cloud native software. Most important, most prominent of it is Kubernetes. So it was founded just after Kubernetes was released by Google back in 2015. It grew explosively. They are a branch of the Linux Foundation, right? So they are founded by the Linux Foundation, but they are kind of independent with their own governance, their own structure. I am proud to be an ambassador for them. We are about 50 in the world, but most important is these people that contribute to the projects. We have a bunch of projects, I think 25 to 28, we keep adding projects, and so if you have an open source project you're working on and you want to be part of the foundation, please submit to the technical committee, and we will look at it. It's very open, very transparent process. It gives you visibility. We bring the project under the umbrella of the Cloud Native Foundation, so under the GitHub organization as well, and then your project is gonna just explode with the foundation. Well, not in a chemistry word, not in the sense of the word, but it will just grow because we as a foundation, I mean, everybody that's part of the foundation, we really believe that cloud native is a concept that is here to stay and is important for the future of what we do, how to deploy and deliver applications, how to build applications in the cloud. So it's all important. We have corporates backing, big ones. Microsoft is a platinum member. Google, of course, Amazon as well, I suppose. So these are some of the projects. So you might know Kubernetes. Maybe you know Prometheus, also the second project to be graduated to graduation, so before you are incubated. And we have a bunch of other stuff, also Service Mesh, Envoy somewhere. Envoy is part of Istio, so we're going to talk about it in a minute. One very cool thing that we publish is this. So it's a bit hard to see because there's so much stuff in there. But this is the landscape of cloud native applications. So just pick your tools. It's nowhere to be. It's not meant to be the end of all landscape. There's probably other projects out there that they are not in this graph, in this picture, but these are what people believe is the most important. So you can build a cloud native infrastructure, a cloud native landscape, picking projects out of this. So, and it's if you go to l.cncf.io, it's actually clickable and you can filter. It's pretty cool. And please join the foundation. I'll be part of it. We have a Slack channel. So, and we do webinars. Sometimes I moderate them. It's fun. But back to the topic. So service mesh. Who knows what service mesh is? No one, really? Right, OK. So service mesh is the new black, right? Everybody's talking about it somewhere, probably not around here. But it's what everybody, all the cool kids are doing service mesh. So we should talk about it, right? But after a while, of course, it's becoming hype. But don't let the hype fool you, right? I mean, when a technology is good, you should look at it. It doesn't matter if so many people are talking about it. People were talking about Kubernetes, and a lot of people are adopted because it's actually technically sound, right? Well, so if you don't know service mesh, at least you know microservices, right? So somebody talk about it. So it's an evolution, right? So it's nowhere, there's no cutoff between these three ways of doing things. Probably most organizations are in between this evolution, this journey, good old days of service-oriented architecture. I wasn't around, I was doing chemistry. So I think I arrived on the scene more or less when DevOps was rising. And nowadays, it's all cloud native, right? So we went from monoliths where we mix business logic and infrastructure. It was really too much of a big bowl of spaghetti that didn't make any sense. Microservices are great because it can separate them. You can treat them as independent units of deployment. And Docker, of course, kind of catalyzed the rise of these things. And today, we are moving even past microservices into this cloud-native architecture where we can have more control because we have this amazing thing called proxies. And Istio wouldn't be there without one of the best proxies out there. Envoy came out of Lyft. And it's written in C++. It's super fast proxy, super lightweight. And I'll show you in a moment what does it mean. So of course, you have one monolith, easy to monitor, easy to control. But when you have more microservices, then the problem is complexity, right? So the whole point of the talk, the whole point of service mesh is to manage this complexity, right? So getting visibility means also control. Otherwise, you end up like these guys, which have all, it's ILO architecture, is the architecture of ILO, found it online. It's not a big deal. You don't want to be there, right? I mean, but if you have to be there because your service, the service you give to your customer requires this plethora of microservices, you do want to have control, right? You can't just let these things evolve by themselves. You have to have some insight. So service mesh really ties your cluster together, right? So it gives you superpowers over your cluster. And it's not difficult to deploy. In fact, we're going to deploy it together. So I'm a software engineer. I like to build things. I don't have any lesson to teach. But we're going to build it together, right? So we start with a Kubernetes cluster. We build together a service mesh. And we do it together because if we succeed, it's good for me. But if we fail together. And we share the failure. It did work last night, so. What is Istio? Istio is a project. It's an open source project, of course. Was initiated by IBM, Red Hat, 2015, around the time, or 2016. Then, of course, when Kubernetes rise to the top of the container orchestration, Istio became kind of the default service mesh for Kubernetes. But it is not limited to Kubernetes. Don't think that if you don't have Kubernetes cluster, you cannot use Istio. In fact, you can use Istio to extend your service mesh from Kubernetes into your traditional infrastructure, into your VMs. There are ways to integrate services around your cloud or on-prem and make them discoverable by your Kubernetes cluster and vice versa. So it's not only Kubernetes, but of course, most of the use cases are around cloud native and thus Kubernetes. So It brings observability, traffic shaping, resilience, and intelligent routing to your cluster, and it does it with a simple thing of adding a proxy to your application. So current version is 1.03, so it's 1.0, right? So it should be production ready. It is. It's used by many people out there. It's easy to deploy everywhere. So there's really little reason not to use it. Of course, like it's another moving part, something that you have to learn. It's not just go for it because I told you so, but have a look at it, and I'll show you how easy it is to deploy. Basic architecture of Istio. So it's made of components, so it's a microservice in itself. Most important are the proxy, that's Envoy, which is injected Kubernetes, right? So Kubernetes is a concept of a pod. So that square there is a pod. A pod is composed of multiple containers. Basically, is the basic unit of deployment for Kubernetes, and it contains multiple one or more Docker containers, and it is kind of a fenced or a cell that has very defined interfaces, very defined barriers around it. It cannot be split. It's one pod, is the unit. It has to be deployed together. So most of the time, your service is deployed as a Docker container in a pod. What Istio does is just injecting a second container in the same pod, sharing the network namespace, sharing the process namespace with your service, and then intercepting all the traffic and managing the ingress and egress from your application. So that simple concept is very powerful because Istio manages the configuration of the proxies centrally through the mixer. So the mixer talks to the proxies and injects configuration, updates configuration dynamically. So if you bring new services to your cluster, these are automatically discovered, and every proxy, every application in your cluster knows about it. What can also do is to have automatic mutual TLS authentication between services. So even if your application is not designed to support HTTPS, there you go, for free, you get HTTPS traffic, so SSL encapsulation between the two applications through the proxies. And all the certificates are automatically managed, renewed, and generated by Citadel, which is another service in Istio. Pilot sends the configuration to the proxy, and there's another one called Galley, which is coming, which also manages the user configuration into your Istio cluster, Istio deployment. So all this is control plane. It never gets mixed with the data plane. Data plane is whatever goes between your application, your services, and Istio always never gets into it. So it's always standing outside, managing things, but never being in the data path, right? So as you do want it. A bit of YAML for fun. I don't know if you know Kubernetes template, how does it look like? So Istio introduced CRDs, so custom resource definition, which are objects in Kubernetes. They are not part of the standard installation of Kubernetes, but they are written by Istio, so Istio can manage its configuration, its gateways as native Kubernetes objects. So when you install Istio, we're going to do it in a moment. We're going to create all these CRDs, and then we have standard native Kubernetes objects to manage, for example, virtual services or destination rules. So that's very simple to understand if you follow me. So an ingress gateway is, of course, like an entry point for your cluster where traffic from outside comes into your cluster, right? So it's think of it like a load balancer or a proxy that sits out just at the edge of your cluster and receives traffic from outside. A virtual service maps your service, your Kubernetes service, by means of the destination host hello world. So I must have a service in my cluster called hello world, and that's matched to the gateway, right? So you can do fancy traffic routing. You can do you can route different API endpoints to different services, and you can have subsets. So that's the whole point, and that's all the demo I'm going to show. So the destination rule basically says, well, this service with this label, the label version v1, put it in a subset called v1. And the version 2 labeled services and deployments, put them in a bucket called v2. And then in the virtual service, you can say, sends 90% of traffic to v1 and 10% to the v2. And that's where all these things ties together, because now we have traffic flowing through the ingress controller into the virtual service, down to the pod, and everything is controlled by the proxy, everything is controlled by you telling Istio what to do. So that's what happens. Very simple. So you have a service. This is not, you can do it from ingress, of course, so getting traffic from outside into your cluster and then fan it out or route it. You can also control service inside your cluster. So service A wants to talk to service B, and that's all controlled by a virtual service, sits in front of the actual Kubernetes service to route, to give some weights to the. So this is a Canary deployment, right? So this is what we're also going to do. We're probably going to do this kind of thing. So we have a blue-green release. Actually, this should be going down a bit, so 90% more like this. And then at some point, they invert. And then you have the new version replacing the old one. You can also do more fancy stuff if you wish so. So because it's a proxy and sits in front of every request, sits in front of all the traffic coming into your service, you can inspect that the traffic and make decision based, for example, on the headers, and send all traffic from iPhone to a different version of your service or a completely different service as well. Another super cool thing is that you can control the traffic between the services, which means that you can introduce latency. So you can do this chaos testing. You can do circuit breaking, made famous by Netflix. So if one service is failing, you don't want to keep hammering that same failing service until your originating service dies because it can't keep up. You want to break that path and maybe fail fast back to the originating service and maybe do something else. But you don't want that service that is failing to drag down your application into a mess of latency and failing requests. You want to kill that thing and move on and fail fast back to the originating service. That's one thing. You can apply network policies, mutual TLS. Any questions about Istio? Is that clear? Well, I assume so. Second part of the talk is, of course, pipelines, not these ones. But we don't like these ones. We like the ones that bring software from A to B. That's all. The whole point here is that, and that's why it's blue-green deployment, because what we want to show is that we want to bring ideas from the brain of the developer down to production as quickly as possible and in the most efficient and automated way, right? So we need a pipeline to bring this software, this code, down to production. That's what we're going to do. So I made my demo over there if you want to write it down or you ping me later. So the demo is about to start. Damn. It's not going to start anymore. So that's where I switch to my amazing terminal. Oh, well. So this is the repo. You can tell that was busy. You do the math when I committed the thing. So it's a simple application. That's how it looks like. is green, right? So that's why maybe we're gonna do a green-blue deployment today, because that's just the last version I deployed, right? So I didn't wrote that myself, but a colleague of mine did. It's a very cool dude, very smart person. He presented at KubeCon. But what it does is that it's a front end, it's a web front end that makes a call to an API, and the API returns a color, and returns the Git SHA that was built with. It's written in Go, super simple. It's in my repo. So this is what looks like the observability. Let me start a quick performance testing of the pool with HTTP perf. So this is how it looks like when you look at this thing. So let's see if we can deploy Istio together, right? So follow me. I mean, stay there, but follow me. We're gonna use cloud, and not any cloud, but the best cloud out there, which is Azure. And in Azure, it's so simple to get Kubernetes clusters in no time, well, about 10 minutes. That's why I pre-provision a cluster. It's called AKS, as Azure Kubernetes Service. I have two, but let's focus on one. So, of course, can you follow? Can you see? Or should I make it bigger? So I'm targeting the first cluster called Mesh. As you can see, I have nothing there, almost nothing. So that's a cluster just like it's freshly deployed. So I have instructions because not that good. I don't remember by heart all these commands. That's how we install Istio, right? So you download the release. It's probably already there. And then the first thing you do, you create this. Yes. This is just the Istio release. And we create the custom resource definitions, which are new objects in Kubernetes. They're all called like config.istio.io. There's a bunch of them. You don't need to know all of them. Some of them are for really fancy stuff that we don't want to know. But you can get them via kubectl get crd. What we're going to work mostly is destination rules, gateways, and destination rules, gateways, and virtual services. These ones. So if you look at my Istio system namespace, well, I didn't deploy anything yet. So that's how you deploy Istio. In fact, there is a Helm chart for that. You know Helm? Helm is like a package manager for Kubernetes. Kind of think of Chocolately or Brew for a Kubernetes cluster. So instead of what I do now, like applying a template, you can use Helm to deploy application in your cluster in a very reproducible way. But I haven't played with the Istio chart enough, so I feel more confident doing this way. So it's creating things, right? It's creating stuff. Soon it's going to be finished. So now it creates the mixer, the pilot, everything. Creates services. Good job, it's going well so far, so we didn't do much yet, but if you have questions, you don't understand, just interrupt me. So this is just what you do to deploy Istio. So we just need this to get somewhere where you can visualize these things. I have two clusters. So one we are deploying together. Another one is ready. It's because I want to show you the pipelines. So I'm just gonna follow through this. So this is the pods in the Istio system namespace. You can tell there's a pilot, there's an ingress, there's Grafana, Prometheus, Citadel, egress gateway, telemetry, which is the Prometheus metric adapter, service for graph. Also very important, that's why most people love, there's a very interesting things of Istio is because you have also insight into your calls between services. So you can have a thing called Zipkin and open tracing. There's also CNCF project to kind of understand what's going on with your class, with your application, if there's a call that is taking too long or that kind of thing. So perfect. So one last thing while we're waiting for this. So by default, Istio is not gonna do anything to your cluster until you tell with this label. So this label this command adds a label to the default namespace that says Istio injection enabled. So now that I did this, every pod that I run in the namespace, in the default namespace, are gonna be subjected to this mutating webhook, which is a thing that sits between you and the API server of Kubernetes that intercept every call whenever you want to create something, and it just injects a little snippet of configuration, a YAML snippet, that adds the Envoy proxy to your pod. So let me see where we are. These are the services. It created Istio ingress gateway. So now, and with a public IP attached to it, so we have a way to talk to our cluster, to our public IP, and it's attached to an ingress gateway from Istio. So, and yes, we are fully running in this thing. So what we can do is to go into where did I put it? Demos. Yes. So all the instructions are in the GitHub. So I have a bunch of templates in here, which I can just apply. Let me show you the templates. So first of all is our web front end. There's a service and there's a deployment. It's very simple, nothing strange here, nothing fancy. It's just a regular Kubernetes deployment, right? So it is not aware that it's under control of Istio. It should not be. The API is a bit more complicated because you have still one service, but of type cluster IP. All services are cluster IP because we don't want to allow these services to talk to the outside without going through Envoy first. So, and you have a deployment called blue and a deployment called green. They're all labeled with version green and version blue. So whenever I deploy this, I'm going to have 3 replicas of one and 3 replicas of the other one. I have a gateway for my web front end, which just links the ingress gateway to my service. I have a web virtual service that says all the hosts, so reply to every way I talk to the, so it doesn't matter the URL that I'm using, just reply to this, connect Mac web gateway with this Kubernetes service, Mac web, right? And now for the API, you have destination rules, which says all the pods, all the deployments labeled version blue, they're in a subset called blue, and all the pods with the version green label in the subset called green. And lastly is the virtual service that sends 50% of the traffic there and 50% to the other one. Simple as this. No. Apply -f. So applies all the templates in the folder. So we got some services over here. Oh, maybe you can see, but there's two cluster IP services, API and web. And then pods, we have one web front end and 3 of each. And notice that there are 2 containers for every pod. Because one is, but it's weird because, right? Because we only define one container in the deployment. So how come we have 2 containers in the actual pod that gets deployed? Because it's intercepted by the mutating webhook and Istio gets injected. And if you really love YAML, you can look at it, get pod. And it's simple. Simple is a big word, but that's, let me see. So this is my original container, right, with my image. And then there's a second container, which is this sidecar proxy from Istio. And all this configuration, you don't need to worry about it. It's managed by Istio, by Mixer, injected, all easy. So we also want mutual TLS to be there, and everything else is managed by Istio. So you really don't need to care about this stuff. What you care is that you have, let me see, from this IP, right? So we have 50% of the traffic to each version. So some are blue, some are green. We can change that easily. Can change that quite easily. API, yes. And you don't need to wait for anything to happen. It just moves instantly, right? So it's Istio, the Envoy proxy, is actually making decision on the fly where to send each packet, each traffic, right? So I just move all my traffic to blue. My green deployment is still there. Oh. I didn't touch deployment, so I'm still running the green deployment. They just don't get any traffic because I told Istio not to do it. Right, so that doesn't conclude my talk. So this is another cluster I deployed because my pipelines are already set up. But basically, I have the same thing, exactly the same thing. So I have green. That's the latest version I built. So the idea is that, well, I don't like green that much. So that's my source code. Say, hey, we don't like green. We like any color? Purple? So the second thing that I want to show that you can, this is all great, but you're not gonna manage your weights via command line, right? That's never gonna happen, right? So we want a way to automate all this, right? So how to do it? So I'm a developer. My boss called me in the middle of the night. I'm a SRE, right? So I'm a SRE. So they told me, hey, we gotta fix this in production right now. So purple. I'm pushing to GitHub, same repo that you can see. So purple just now, what does it do, this? So I guess people know and love Azure DevOps, aka VSTS, or who knows next year what's going to be called, but that's, it's a great system, actually, I love it, but it's still something that I don't really like, but we can talk about it later. But this triggers a build, which is defined by this little file. Thank God we have a YAM file for build definitions. So it just builds my API with the new version and tags the version with the git commit. So it's good. So this should take about 4 minutes. Well, no, this is pretty fast because it's Go. So what it does is take the code, check out the code, the latest version, so the one with the purple color, build the Go executable, put it in a Docker container, send it to GitHub. That's all fine. That's all easy. The thing comes after this, so I get some time, so I'm not worried. By the way, I was. Let me do it 10 times. Just HTTP perf to show that there is actual traffic going on. I'm not dreaming this. Right? Yes. So there's actual traffic going on. I hope I'm not DDoSing my application. So the build should be almost there. You can do the same with CircleCI, GitHub, whatever, GitLab. So the build is done. Let's go to release. So I build up a release pipeline that is made of a bunch of steps. So it takes this new tag, injects the new tag into dev. So you can call it dev, production, blue, green, doesn't really matter as long as you identify clearly what is before and what is next, what is there and what is gonna be there. So the second step is applying 90 and 10 weights via Elm. So Elm, again, it's all explained in the repo, but we control this easily with Elm. And then it stops. Well, yeah, because this step requires human approval. Because I want to see, actually, with my own eyes, is if purple is purple, what kind of purple it is. If you give it a second, it's not done yet. Kind of fast. I mean, it's faster than. Of course, while you do this, you don't need to talk to an audience. You probably go grab a coffee or something like that. But yes, so 10% of the traffic goes to the purple version, right? So it's actually happening. I'm not dreaming this. I like purple. What do you think? Shall we approve? So 10% of the traffic, this web front end makes a bunch of calls, so it's not very scientific, but rest assured, some part of my customers, clients, users are looking at this purple version right now. Of course, this is all for nothing if you don't have metrics that actually connects this experiment with your pipeline. So now I'm approving because I like purple, but gotta be a bit more scientific about this. But say that I approve purple because, well, I'm not the Queen of England. And yes, so now it's gonna move all the traffic to the new version. So soon enough, I'm gonna see all purple in there. soon enough. Wish it was faster. But it takes the time it takes. So, there you go. So, experiment is a success. I love purple. Now my site is all purple, right? So, and the rest of the steps are injecting the new image tag into what was called production, and then switching the traffic to production as well. So the next experiment can start over by injecting 10% of dev. That's it. That's more or less what I have. So, and trust me, this was fun to build, except for a few things, like passing variables between builds and releases. Hell of a job. And if you have questions, you can find me on Twitter, email, LinkedIn. You can come over to Amsterdam for a meetup. We have one next week. And you can do all this by subscribing to our trial with Azure. You got $50 or $100, which is plenty to start working with Kubernetes and Azure DevOps. I think is included in the old. I think Azure DevOps is even free for public repo. So this is a public repo. Also the pipeline, it's free. It's well, you can see it actually in my repo. You can see that build succeeded. So questions? Yes.
Hold on one second.
Because I think they are not in the code. Oh, sorry.
Hang on, try that again.
No.
Is there any chance to see the release steps?
Yeah, I wish releases could be expressed in YAML.
Yeah.
They don't. Yeah, tell me about it. It's coming. It's coming, this release YAML definition. But it's basically this. So I'll show you. It's quite straightforward. So the first thing is to inject a new tag. So you take a variable. So before the last step of the build is to write the image tag into a file. Then you take that file in the artifact. You get the artifact, and I know it's PowerShell. I don't know PowerShell, but I found it. So this gets that file and put them in a variable that is used by this command, which is kubectl set image deployment. So this change the deployment of the API to use the new tag. That's it. So Kubernetes deployments will recycle all the instances of green with the new tag. So it's going to kill the pods with the old version and spin up 3 more with the new version, right? If there's something wrong, the deployment has a built-in fail-safe. So if the pod doesn't come up healthy, the deployment will stop midway, and this whole thing will stop. So, but because I didn't introduce errors, then the deployment can continue to deploy the new version, new image tag. The second task is to apply. So there are Helm steps built in Azure DevOps. Unfortunately, you have to first install Helm for some reason. But then this is as simple as changing the weight. So this is a simple, very simple Helm chart that does one thing. Takes that virtual service and change the 2 numbers. That's it. Nothing, no. Now I say, but it's actually very complicated to build. I mean, it takes a software engineer to build, of course. It's just YAML. And then it goes on, it waits, and then applies. It's the same task, really. And then one thing I did is to build a manual rollback push button thing, because it cannot do it automatically. It can say, oh, if I don't approve, then reject, and then roll back automatically. No, it's not there yet. Maybe there's some PowerShell trick, which I don't want to learn, but I'll just wait until they build it. So the idea is that if I don't approve, I have a button that I press, and I'll roll back to whatever it was at the beginning, which is production 100, dev 0. That's it. Any more questions?
Brilliant. We are running a little bit over because we started a little bit late. Your time is good.
Okay.
But no, that's awesome. If anybody wants to stick around and ask any questions, I'm sure Alessandro's happy to. I'm volunteering your time up. I hope you don't mind, but I'm sure you're happy to answer a few questions during the break. We should have broken 5 minutes ago. We've got 15 minutes for you guys to grab some coffee, and then we're back in here at 10 to 4 with Andy Collin from ThoughtWorks, who's going to talk about increasing deployment frequency. So thank you very much. Thank you, Alessandro. That was brilliant. It was really, really insightful. Some great stuff. Thank you.